So after Dalton's law of partial pressure, the next concept which we are studying is Graham's law of diffusion. So what is meant by Graham's law of diffusion? See, any gas, if it is at a higher concentration, Subara. Oh, okay, ma? So if any gas, if it is at a higher concentration, then always it tries to flow from higher concentration to lower concentration, so that density of the gas, or you can say concentration of the gas or pressure of the gas reduces. So that process is called as diffusion of a gas. Okay, ma? So the process in which the density of the gas reduces, concentration reduces, or you can say pressure of the gas reduces, that concept is called as diffusion. Okay, ma? So diffusion of a gas, it depends on these many factors now. So R is proportional to A into P divided by root D. Or you can write separately, R is proportional to A, in which condition when P and D are constant. That's all. So I can say rate of diffusion is directly proportional to pressure, in which condition when A comma D, when they are constant. Similarly, I can write R is inversely proportional to root D, in which condition when area and pressure, when they are constant. Are you able to understand, ma? So if you combine all of them, then I will get this relation. So R is equals to A into P divided by root D. Now what is A here? A means area of the hole which you have made in that container. Okay, ma? Or you can call it as area of the orifice. Area of orifice. Okay, ma? Orifice means hole. So if you make a hole in a container, gas leaks out, no, ma? Why gas leaks out? Because inside the container pressure must have been greater. So gas always tries to flow from higher pressure region to lower pressure region. So A is area of the orifice. What is P? P is called pressure of the gas. Okay, ma? And D is called as vapor density of the gas. Okay? Or D you can write it as V into D also, vapor density of the gas. Are you able to understand, ma? So these are the three conditions on which rate of diffusion of a gas is depending upon. Rate of diffusion means how much gas is diffused per second. That is called as rate of diffusion. Okay, ma? Now here also I can write, see, ma, I will take this relation. So R is proportional to 1 by root D, in which condition when area of the orifice and pressure, when they are constant, then I have to write this relation. Are you able to understand? And here there is one more relation. Molecular weight of a gas, this is equals to 2 times of vapor density of a gas. So this is one more relation which you should remember. Okay, ma? What is the relation between molecular weight of a gas and vapor density? So molecular weight of a gas is 2 times of vapor density of a gas. Clear? So therefore, if R is directly proportional to 1 by root D, then also I can write R is directly proportional to 1 by root M also, no? I cannot like this also, no? Because molecular weight and vapor density, they are directly proportional. So here instead of vapor density, I can write capital M also. What is meant by capital M? Molecular weight of a gas. Okay, ma? So this is a very important relation, and this relation itself is called as Graham's law of diffusion. Are you able to understand, ma? So Graham's law of diffusion says that the rate of diffusion of a gas, it is inversely proportional to root of molecular weight of a gas. So all these are gas laws only, and this is a very important derivation which we have done. Are you able to understand? Okay. Similarly, we can write, see, ma, if, and here this is proportional to root M, in which conditions? Conditions are A, comma P, comma T. T means the temperature. Okay, ma? They should be constant. Are you able to understand? Area of the orifice, pressure and temperature. Pressure and temperature, they are interdependent. Okay, ma? So area, pressure and temperature, if they are constant, then I can write this relation. Okay. And if pressure is a variable, if pressure is a variable, okay, then how I have to write? Then I have to write R is proportional to, here I have pressure, no, ma? So pressure divided by root M. This is how I have to write. So if pressure is a constant, then I can remove pressure. But if pressure is a variable, then I have to include pressure also, no? So R is proportional to P divided by root M. This is how I can write. Are you able to understand? Okay, ma? So after that, if I take two gases, now here I have discussed only about one gas, no? Now if I take a mixture of gases, or if I'm comparing two gases, okay? So if I take two gases, then how I can write R1 by R2 is equals to square root of M2 divided by M1. I can write like this, no? Where R1 is the rate of diffusion of first gas, R2 is the rate of diffusion of second gas. So R is inversely proportional to root M, no? So if I write R1 by R2, then here I have to write M2 divided by M1, because they are inversely proportional. And here what are constants here? Here pressure is a constant, area of orifice is a constant, temperature, it is a constant. These are the variables which are constant. Are you able to understand, ma? Now if pressure is a variable, if pressure is also a variable, then can you say how can I change this equation? If pressure is also a variable, then I have to include pressure also. And what is the relation between rate of diffusion pressure? Directly proportional, inversely proportional? Directly proportional, no? So therefore how I have to write R1 by R2 is equals to P1 by P2 multiplied by square root of M2 divided by M1. So I can write like this also, if pressure is a variable. Okay, ma? So whenever he gives the gases in terms of moles, mole fraction, mass of the gas, if he measures these kind of things in the question, then it means definitely pressure is a variable. Are you able to understand, ma? What are the terms you have to search for in the question? Number of moles, mole fraction, weight of the gas, mass of the gas, two different gases. So if he is comparing about two different gases, and if he is using this terminology, then you have to remember definitely pressure is also a constant. Because pressure depends on what? Pressure depends on what? Pressure depends on number of molecules or number of atoms, no, ma? So if number of atoms or number of molecules will change, pressure will change, no? Clear? For example, if you take 1 mole of hydrogen and 2 moles of oxygen, which will give more pressure on the container? 2 moles of oxygen will give more pressure, because 2 moles are there means double molecules are present, double molecules of oxygen are present when compared to molecules of hydrogen. So automatically oxygen will give more pressure. So if pressure is also a variable, definitely you have to include pressure also in the given relation. And in the question, if he gives 1 mole of hydrogen and 1 mole of hydro-oxygen, then pressure is not a variable, no? Are able to understand? Initial pressures remain to be same, because already we have studied Avogadro's law. No? What is Avogadro's law? If you are taking containers of similar sizes of the containers, if they are same, that is volume if it is same, pressure if it is same, temperature also if it is same, then every container will have same number of molecules. That is Avogadro's law, no? Are able to understand, ma? So similarly, if volume is same, temperature is same, pressure is also same, it means definitely number of moles of the gas also should be same. So if number of moles, if they are same, then pressure is not a variable, pressure is a constant for both of them. Then you need not use pressure here. Are you able to understand the difference, ma? So you better make a note of it. Okay. So note point. So check for pressure. If it is variable or not. Okay, ma? If same number of molecules exist, same number of molecules, I can call it as moles also, no, ma? Moles also. If number of moles are equal, the number of molecules are also they are equal. So if same number of molecules exist, then pressure is a constant in both the gases. Clear, no, ma? But if number of molecules, if they are not equal, then Evandre ఇప్పుడే టిఫిన్ చేసినా కదా. Are able to understand? So always you should check for pressure. Okay. Similarly, we will write some cases also. What are the cases we will write? Cases are there if you want to write the rate of diffusion in terms of length of a gas. For example, he will give some questions. He will give two molecules on different sides, and there will be a glass tube. Okay, ma? So diffusion of one gas and diffusion of other gas may be different, So some gas they travel faster, some gases they travel slowly. Are you able to understand? So if they travel in a particular length of a glass vessel, so what is the distance covered by each, each gas? So questions can be asked like this also. So we will do one question on that. So therefore, if question is given on in terms of length traveled by gas, length traveled by gas, it means he says that oxygen gas has traveled 8 centimeters of length, oxygen gas, helium gas has traveled another centimeter. So like that question can be given in terms of distance traveled by gas also. Clear number? Then in that condition, the rate of diffusion R1 by R2 is equals to okay, Sima. So we have studied equations of rate of diffusion, Nama. Now we are studying some more equations for rate of diffusion, ma. So first one is rate of diffusion in terms of length traveled by the gas. So previously we have done one problem, Nama. For example, in this one NH3 gas was present and here HCl gas was present. And both of them, they were connected by some tube. Are you able to understand, ma? Then the gases start diffusing and each gas covers a different distance depending on their molecular masses. That's what we have studied, no? So therefore, if I know what is the length traveled by each gas, for example, if ring was formed here, ring means NH4Cl. NH4Cl ring, if it formed here, then NH3 would have traveled this much distance and HCl would have traveled this much distance. That's all, Rama. So what is the length traveled in a particular time? Similarly, what is the length traveled by second gas in a particular time? That is equals to square root of m2 divided by m1. That is the actual meaning of this one. Clear, number? Similarly, in terms of rate of diffusion, in terms of number of moles of gas which has diffused. So here N1 doesn't indicate the initial number of moles. N1 indicates the number of moles of the gas which has gone out of this cylinder. Number of moles which has escaped, which has diffused. Are you able to understand? So N1 by T1 multiplied by T2 by N2, it is equals to square root of M2 divided by M1. Clear, number? Similarly, in terms of volume of gas diffused. So this is length traveled, this is number of moles, and this is how much volume of the gas has diffused out of the holes or out of the opening. Then again, same format of formula. V1 by T1 multiplied by T2 by V2 is equals to square root of M2 by M1. Clear, number? And the last one, in terms of mass of gas diffused. Are you able to understand? How much mass, or you can say how much weight of the gas diffused. Already we discussed in chemistry, mass and weight both are same, number. So therefore, W1 by T1 multiplied by T2 by WT is equals to here square root of M1 by M2. In all these you will write M2 by M1, but here you will write M1 by M2. So W1 and W2, they are not initial masses. They are masses which have diffused, which has gone outside the cylinder. That is called W1 and W2. Understood, no? Already you have written, no? Okay. So this is the question. Two balloons are filled with equal moles of hydrogen and helium. It means one balloon I am filling with hydrogen gas, and in the second balloon it is filled by helium gas. Okay, ma? So which balloon? So I am making same size holes. It means area of the orifice is constant. That is what is meant by same size of holes, no? So same size of holes represents what? Area of the orifice is constant in both of them. So rate of diffusion, already we have written it is A into P divided by root D, no? Clear? So area is same. And one more point which I understand is equal number of moles, he said. So pressure is also a constant. So therefore I can write pressure is also a constant. Okay. Then if you make same size of holes, which balloon will contract first? Can you say? Which balloon will contract first, ma? Contracting means small size. Which balloon's size will become smaller? So the balloon which loses more gas, that will contract first. So which balloon will lose more gas? So these two are constants, no, ma? So R is proportional to 1 by root D. Okay, ma? And density, molecular weight, they are constant. So 1 by root 1 by m. This is what I have to write. Clear, no? So therefore, rate of diffusion R1 by R2 is equals to square root of M2 divided by M1. This is how I am comparing two gases, no? Definitely I can write like this. Okay. So rate of diffusion of which gas? Hydrogen gas divided by rate of diffusion of helium gas is equals to square root of molecular weight of helium gas divided by molecular weight of hydrogen gas. So what is the molecular weight of helium gas? Helium 4. So therefore I will write 4 divided by hydrogen gas 2. So 4 divided by root 2. Clear now? So therefore RH2 is equals to root 2 times of RHE. This is what I have to write now. Okay. So the rate of diffusion of hydrogen, it is root 2 times greater when compared to the rate of diffusion of helium. So which gas diffuses fast? Definitely hydrogen. Its rate of diffusion is greater, no? Root 2 means 1.414. It means 41% greater rate of diffusion is present for hydrogen when compared to helium. So when you make same size holes, so hydrogen gas escapes very fast when compared to helium. So hydrogen balloon also will become very smaller when compared to helium balloon. Okay. So therefore what I say, rate of diffusion of hydrogen is greater than rate of diffusion of helium. Therefore H2 balloon contracts fast. Contracts faster when compared to helium balloon. That's all. Okay, ma? So this is the question. So a bottle of dry NH3 and a bottle of dry HCl, clear ma? They are connected to a long tube and they are opened simultaneously. Okay ma? So the white ring means what? See my NH3 and HCl, when they react with each other, then NH4Cl will form, no? So this is white in color. So white ring formed, it will be closer to what? That is, will it be closer to NH3 or will it be closer to HCl? That is the question. Okay. So consider these are two boxes. Okay ma? And here I have NH3 and here I have HCl. So both of them, they are connected by a tube. Clear? And both the tubes, they are opened. Okay ma? Then a white ring will be formed, and the white ring is definitely NH4Cl. It means, so from this cylinder, NH3 starts diffusing, no? And from HCl cylinder, HCl starts diffusing. So both of them, after reaching somewhere, they react with each other. Okay? And wherever they react, a ring will be formed. So this ring will be formed, will be closer to NH3 or closer to HCl. How can you say? So everything depends on what? Everything depends upon molecular masses only, no ma? So therefore what I say, therefore rate of diffusion is directly proportional to 1 by root m. Okay ma? See ma, here he did not say anything about mass, anything he did not say about mole fraction, anything he did not say about number of moles. It means we have to consider pressure to be constant. Are you able to understand? So this is very important point. So make a note of that point. So note point of what? Okay. Anything about MTG. Okay, ma? So anything about moles, mole fraction, weight, nothing is given. Is not given. Okay, ma? Then consider, what we have to consider? Then consider pressure is a constant. So in both of them, we assume that same amount of pressure is present. Okay, ma? If he said anything about that, then we should have taken that one into consideration. He did not give anything about a number of moles, no? So in such situations, you have to take pressure to be constant. Okay. Now, what is the molecular mass of HCl? Okay, ma? Hydrogen is 1, so chlorine is 35.5, so total 36.5 grams. For 1 mole, this is the molecular mass, 36.5 grams. Similarly, which is the another one, ma? NH3. Okay. Nitrogen, 14 plus 3, how much? 70. Okay. So therefore, which mass is greater when compared to which mass? Definitely, the mass of HCl is larger when compared to NH3. Clear nama? So which gas will diffuse very fast? NH3 diffuses very fast. Why? Molecular mass is very less, no? If molecular mass is very less, rate of diffusion will be very fast. Clear, no? So this gas, it travels, it diffuses very fast. And HCl will diffuse very slow because its molecular mass is bigger. Okay, ma? So therefore, where this white ring will be formed, ma? White ring will be formed very close to HCl. Are you able to understand? That's our answer. Okay. So therefore, what we write as molecular mass of HCl is greater, it diffuses slowly. It diffuses slowly. Therefore, a ring is formed. A ring is formed closer to HCl. That is the condition. Clear? That's all. Okay, ma? So this is the next question. So 0.5 moles each of hydrogen, sulfur dioxide and CH4, they are kept in a container. Are you able to understand, ma? So a hole was made in the container. So it means all of these gases, they are present in the same container. Okay? Previously we have taken different containers, no? But here all the gases, they are present in same container. And every gas is of 0.5 moles only. What do you understand? Pressure is a constant. It means every gas will exert same pressure on the walls of the container. Are you able to? Because number of moles, they are same. So therefore what we write, first observation is number of moles are same. Number of moles are same, is same. Grammar osari gurtu techukondi. But we are measuring to number, no? But we have different gases, no? Number of moles is same. I think that is correct. Okay, ma? So therefore, they are kept in a single container. So therefore, what I can say, therefore, pressure is a constant. So every gas is exerting same pressure on the walls of the container. So if pressure is same and the hole is also same for all of them, no ma? So therefore, area of orifice is also a constant. And after 3 hours, so time taken is also constant. Clear? Then in that condition, rate of diffusion is inversely proportional to root m. Okay? So which gas has highest molecular mass, that gas will diffuse very slow. Okay? Now let us calculate molecular masses of each of them. So molecular mass of hydrogen is how much? So it is 2. Molecular mass of sulfur dioxide is how much, ma? 16 plus 16, 32 plus 32, 64. Clear, no, ma? So molecular mass of CH4. So 4 plus 12, 16. Okay, ma? These are the molecular masses. Understood, no? 2 grams, 64 grams and 16 grams. So therefore, which is having least molecular mass, ma? Hydrogen. So this gas will diffuse very fast. Hydrogen will diffuse very fast. And next followed by CH4, next followed by SO2. So after 3 hours, which gas would have gone by a very large quantity? H2 would have gone by a large quantity. Next followed by CH4, next followed by SO2. So which gas is present in more number of molecules in the container? SO2 is present in more number because it is not diffusing very fast. No? Okay, ma? So for this gas, if 10 molecules are escaping, for this one 4 molecules are escaping, and for this one only 1 molecule is escaping. Clear? No? So the number of molecules of SO2, they are very large, which are present inside the container. I am not discussing about escaped molecules. I am discussing about those molecules which are present inside the container. So inside the container, more number of SO2 molecules are present. So automatically pressure given by SO2 will be greater. Okay? Because more hydrogen molecules will escape. Followed by CH4, then followed by SO2. So therefore what I write? Therefore I write more number of Hashish, IP చదివి బ్రెయిన్ పనిచేయటం లేదు కదా. కరెక్టే కదా, అర్థమైంది నాకు విషయం. సో మోర్ నెంబర్ ఆఫ్ H2 will escape compared to CH4 and SO2. Okay, ma? Therefore, in the container, more number of SO2 molecules are present, followed by whom? Followed by CH4, and again followed by finally whom? Followed by H2. Clear? Therefore, partial pressure of sulfur dioxide is greater than partial pressure of CH4 is greater than partial pressure of H2. Clear? Understood now? So, that gas which has more number of molecules, it will show greater pressure, because already we discussed that pressure is directly proportional to number of moles or number of molecules of a gas. No? Which gas is escaping by large quantity? Hydrogen. So finally its pressure will be very less after 3 hours, because only less hydrogen molecules are present, but more SO2 are present. So pressure of SO2 will be greater. That's it. But initially pressure was constant. This is the point which you should understand. Before making a hole, pressure given by every gas was same. But after 3 hours, pressure given by each gas will be different. That's it. Okay, ma? Okay. So let us see this question, ma. So 4:1 molar mixture of helium and CH4, okay, ma, is contained in a vessel at 20 bar pressure. Okay. So due to hole in the vessel, the gas mixture leaks out. What is the composition of the mixture diffusing out initially? Okay. So first let us see what are the values which are given. Molar mixture is given, no, ma? So it means number of moles of helium divided by number of moles of methane gas. They are 4:1. This is the first data which is given. Okay. So same relation I can write pressure of helium divided by pressure of CH4 also. No? This is the first information you should write down, because already we discussed that what is the ratio of moles, same is the ratio of pressures also. If number of moles increases, pressure also increases. First information which you should get, otherwise you cannot get the answer. Understood, no? So therefore definitely pressure is a variable, no, ma? Pressure, is it a constant? No. Pressure of helium, it is 4 times greater when compared to pressure of methane gas. Understood, no? Therefore what I can say, therefore pressure is a variable, it is not a constant. Okay. So hole is made, so gas leaks out. So time of leaking of gas is same for both the gases, no? Because from same hole both the gases they are leaking out. So therefore times taken also they are same. So therefore this is the question based on number of moles of a gas and pressure of the gas. Therefore how can I write a relation? N1 by N2 rate of diffusion, R1 by R2 is equals to, I can write, already we have written an equation, no, ma? So N1 by T1 multiplied by T2 divided by N2 multiplied by square root of M2 divided by M1 multiplied by P1 by P2. This is what I have to write now. Clear, no? Additionally, I have written P1 by P2 also. Why? Pressure is a variable. So definitely rate of diffusion is directly proportional to pressure. Okay. So time and time will get cancelled. Now just substitute all of them. That is our answer. Clear, no? So first of all, let us take a rate of diffusion of helium divided by rate of diffusion of CH4 is equals to N1. What is the number of moles of helium? 4:1 ratio multiplied by square root of, what is the molecular mass of CH4, ma? 16. Molecular mass of hydrogen, helium 4. Okay. So multiplied by P1 by P2, same as that of N1 by N2, because already we have discussed that concept, no? So again now 4 divided by 1. So do the calculation. So 4 by 1 multiplied by 4 by 1 multiplied by how much? 2. How much is this one? 4, 2. 4, 2. This is what I will get now. but I am getting a different answer. Helium. So I am writing a square root of CH4 by helium. Helium 4 only, nama. Atomic number is 2, molecular mass is 4. Helium single atom only, no? Inert gas, nama. It never reacts with another. Helium, atomic number 2, nama. Mass number 4. Correct only. But what is the value I am getting? Number of moles 4:1. Pressure 4:1. Everything is correct only, no? So therefore, what is the ratio I am getting? 32:1. I am getting, is it? Maybe 32:1. Let us check the answer. Okay, ma? So here N1 by N2 is equals to P1 divided by P2. This is equals to 4 by 1. Clear? Therefore, the equations are rate of diffusion R1 by R2 is equals to N1 by T1 multiplied by T2 divided by M2 is equal to square root of M2 divided by M1. And here pressure is a variable, no, so I will write P1 divided by P2. So this is the additional equation. Okay. So if pressure is not a variable, definitely no need of P1 by P2. But here number of moles are different, no? So pressure also will vary. Okay. Now just do this calculation. So therefore R1 by R2 is equals to times of gas diffusing is same, no? T means time here. Number of moles are how much? R by 4:1 is equals to square root of 16 by 4 multiplied by pressures are 4 by 1. Clear, nama? Therefore, what is its calculation? How much, ma? So here also I have to multiply by P1 by P2, ma? On both sides I have to multiply, no? So therefore, what is the calculation I am getting? 4:2. So 2 into 4 divided by 1, this is equal to 8:1. Okay. ఇక్కడ 2 వస్తుంది కదరా. 4 2 8 కదా. ఈ పక్క కొంచెం వేరీ అవుతుంది, అదే ఏమవుతుందని చూస్తూ ఉన్నా.